In this video, we'll look at how to solve equations that have more than one variable for one specified variable. This is also called literal equations, literal meaning letter. So in these examples, you'll see that we have a bunch of different formulas and equations that have more than one variable, but we want to rearrange each equation so that one of the variables is, or a different variable is isolated. So the methods that we use are the same methods that we use for solving equations where we only have one variable. We're going to try to isolate the variable that we're interested in by adding, subtracting, multiplying, or dividing on both sides of the equation. But now we might be dividing by a variable or adding a variable. So we might not be able to actually do the operation, but we'll just write the operation as an expression. So let's take a look at each of the examples that you see here. So we'll go through 4 in total. Notice again, for each one you need to be told which variable that you're solving for. So in this first equation, we have y equals kx. We want to rearrange it so that k is isolated. All right, so I have the equation written here. Again, y equals kx, and we're solving for k. So we want to think about and focus on the variable that we're looking for, which in this case is k, and just think about what is happening to that variable. So here k is being multiplied by x. The opposite of multiplication is division. So instead of multiplying by x, we will divide by x. We show division with the fraction bar, and whatever we do on one side, we're going to also do on the other side. So we know that x divided by itself is 1, and 1 times k is just k. Y divided by x, well, we don't know what y and x are, so we just have to leave it as the expression y over x. So once you have the variable that you're interested isolated, you're done. It doesn't matter if the variable is isolated on the right-hand side or the left-hand side of your equation. You could always just rearrange it if you want to by putting the variable on the other side. It doesn't change anything. One thing that you should keep in mind if you're working on homework, the case of the variable matters. So if the variable is given in lowercase, you need to write it in lowercase. If a variable is given in uppercase, then you need to write it as uppercase. Otherwise, the software will recognize it as incorrect. There are often formulas that have the same letter, but one's an uppercase and one's a lowercase, and that makes a difference, so they might have different meanings. In the second example, we're looking at the formula for a triangle. Actually, area equals 1/2 base times height, but we want to rearrange the formula so that the height is isolated. So we're solving for h here. All right, so here again, I want to recognize what's happening to h. H is being multiplied by b and multiplied by 1/2. So there are a couple of different ways you could approach this. You could undo the multiplication one at a time, or you can try to undo both multiplications at the same time. In this case, because I have 1/2, a fraction, instead of dividing by a fraction, I prefer to multiply by the reciprocal, because that's really what you end up doing with a fraction anyway. So we're going to start by multiplying both sides of this equation by 2. I'm going to show that in a different color just so it's a little bit easier to see. So times 2, and then times 2 on the other side. It doesn't matter when I multiply, if I multiply on the left or the right hand side. Now when I do that on the left side here, I have 2a equals, this 2 is going to cancel out with the 1/2 because they're inverses, multiplicative inverses, so when I multiply them I get 1. So I'm left with bh. Again, I want to solve for h. I want to isolate h. H is still being multiplied by b, so I'll undo that multiplication by dividing, and I'll divide on the other side as well. B divided by b is 1, so I'm left with h, and then here I can't do anything, so I'll just rewrite it as 2a all over b. And again, if you want to rewrite it so that h is on the other side, you can certainly do that. Okay, in the next example we have an equation with two variables x and y, and we want to solve this equation for y. We also have fractions in this equation, so we could use the strategies we've had in the past for fractions. Right, so if I want to clear out the fractions first, I'm looking for the least common multiple of 2 and 3. The least common multiple of 2 and 3, I'll just write that up here, so LCD or LCM, whichever you want to call it. I'll call it LCD, that's what we did in the past. The least common denominator of 3 and 2 is 6. So I'm going to multiply all of the terms of this equation by 6. So everything on the left-hand side by 6, or 6 over 1 in fraction form, and on the right-hand side I'll multiply by 6 as well. Alright, so here I have 6 times 2 is 12, divided by 3 is 4, so this term becomes 4x. 6 times 5 is 30, divided by 2 is 15, so negative 15y, equals 5 times 6 is 30. Now all I did there was clear out fractions. Remember, we wanted to solve this equation for y. So now I could do that by isolating the term that contains y. So I want to get rid of this x term here. It's a positive 4x. I will subtract 4x. Do the same thing on the other side. So I have negative 15y equals, now these are not like terms, so I can't combine them, but I can just rewrite it as 30 minus 4x. It doesn't matter which order you have those terms in. If you want to write negative 4x plus 30, you can do that. Remember what we're trying to do, we're trying to solve for y. Y is still being multiplied by negative 15, so I want to divide by negative 15. I'm dividing everything on the side by negative 15. I'm going to divide one term at a time. Alright, so now we'll go ahead and simplify. Negative 15 divided by itself is 1, so that becomes y equals 30 divided by negative 15 is negative 2. Negative 4x divided by negative 15, well, 4 and 15 don't have any common factors, but I can simplify because I have two negatives. So two negatives when we're dividing becomes a positive, and I could just write that 4 over 15 as a coefficient, a fractional coefficient, and then x. I could keep the x in the numerator if I wanted to, next to the 4, or keep it out next to the fraction, but I don't want to put it in the denominator. And again, we're solving for y. Y equals negative 2 plus 4/15 x. And if you have these two terms in a different order, that's okay as well. So if you have the 4/15 x first and the minus 2 second, that's certainly equivalent. All right, in our last example, so we're solving for x in the equation ax equals bx minus c. So here I have the variable that I'm looking for in two different terms. This is probably one of the hardest examples like this, when the variable that you're solving for is in two different terms. So the first thing you want to do is get the terms that have the variable isolated. So since I have this bx on the right hand side and that has another term that doesn't have x, I'm going to subtract bx from both sides. This way, on the left-hand side, I have ax minus bx. Both of those terms contain x, which is what I'm looking for. On the right-hand side, I have minus c. Don't forget that minus sign goes with that c, so that should stay there. Now, I need to combine these two terms because I want to have the variable in one term. In the past, when we combine like terms, we combine the coefficients. So don't think of these letters A and B as letters, think of them as numbers. If they were numbers, you would combine them, A plus negative B or A minus B. So whatever they are, we could find out what the coefficient would be by actually combining A minus B. So the coefficient of x now becomes that expression, and I'm putting that in parentheses because I would combine those first and then multiply by x, and that's equal to negative c. So now I have combined these two terms. I have one term here now, and this a minus b, whatever that quantity is being multiplied by x. The opposite of multiplication is division, so I will divide by a minus b, and then do the same thing on the other side, divide by a minus b. I don't need to write the parentheses because this fraction bar actually acts like a grouping symbol as well. If I put those parentheses at the bottom, it doesn't make a difference. Just to clean this up, the a minus b's cancel, and I have x equals negative c over a minus b. If you wanted to, often when we have a negative fraction, we write the negative in front of the fraction instead of putting it in the numerator. So negative fraction bar with a c in the numerator and a minus b in the denominator.